A lot of people kind of have an image of the ocean as this kind of glorified bathtub, you know, this huge thing with water that's the same, the top to the bottom, and that's really not the case. It's much more like, I don't know, some sort of sandwich or lasagna maybe. You have very distinct ocean layers and currents, these what they call water masses.
The two big dictates are water temperature and the amount of salt dissolved in the ocean. Those two, temperature and salinity as we call it, it controls the density of the water.
The heaviest water sinks right to the very bottom of the deep ocean, while the lightest water will stay in the surface. And so if you were to take a section of salinity or temperature through the ocean, you can see these different water masses, these different bodies of water, and trace where they've come from just by their temperature and salinity, which are properties that are given to them at the surface that they then sink with and circulate with, without those properties really changing very much, all the way throughout the deep ocean.
So you'd cross a current, or you'd cross an ocean basin, and you'd map the way these properties change. And so you map that in space, and then if you're lucky enough, if you've got the funding, you go back and do it a couple of years later and see how it changes, or you see how it changes with the seasons, or you see how it changes with climate change.
The main role of the ocean is that it's the temperature flywheel in the climate system. It's the beast that keeps moving. It's the beast that keeps moving warm water north in the North Atlantic, keeps cold water going into the ocean interiors around the poles. It's the ocean that then can warm the atmosphere and set what we feel as climate, which is, you know, what we see on land. It's the warm oceans, say in the North Atlantic, that keep Europe warm.
The way I like to look at it is that the entire heat content of the atmosphere, the amount of thermal energy it can store, you can squeeze that into the top 3 to 4 meters of the ocean, because the ocean's way deeper than that. So it has this massive capacity to store heat.
It takes a long time for the ocean to get warmer, and it also takes a long time for the ocean to cool down.
The ocean right at the moment, at this time of basically a warming planet, is taking that heat up and storing it. So if the planet stopped warming at its current rate, the ocean would still be this vast store of heat, and so the effects of warming will be prolonged well after any atmospheric warming took place.
I wouldn't even want to put a time scale on how long you would want it would take for equilibrium to reach the base of the ocean.
Yeah, it does set the pace of climate change. So if we're going to understand how the climate on the Earth is changing, we need to understand how those ocean currents may be changing.